Once we are able to use decision statements in our code, it opens up all kinds of new possibilities, including simple games. So for this video, I'm going to do a sample walkthrough for one of the unassigned problems in the textbook that asks us to create a rock, paper, scissors game. This kind of a video is much more useful if you pause the video here, make your best attempt to solve the problem yourself, and then come back and watch how I solve it. So now's a good time to stop and make your attempt. I always point out that as I do these solution walkthrough videos, I don't plan ahead very much. I jump in and start writing code because I think there's value in students seeing the process and seeing that even good experienced programmers make mistakes and have to go back and fix them, and things don't always work out perfectly. So I don't know if that'll happen in this video, but often it does, and I generally do not edit that out. In this case, the first decision we have to make is about user interface. We could make a GUI program with Windows Forms, or we can make a console application, and the problem doesn't specify. I think it's possible that a GUI program would be slightly easier to implement, and so for that reason I'm choosing to go with a console application, but either is fine and either is going to be essentially the same. And as always, I start off with a header block here that I've pre-typed so you wouldn't have to watch me fumble through it. And the test cases are going to be interesting for this because there's an element of randomness. And so we'll talk about testing once we've got enough of the code done to be able to do that. But I want to acknowledge up front that it's going to be kind of tricky to test this thoroughly. And for games that are very complex or random simulations that have a lot of randomness to them, that's a difficult process, and so we just do the best that we can in this instance. I'm going to think ahead about my program a little bit and say that, well, I generally use a similar kind of structure to my code anyway, but the first thing I'm going to do is decide what all my variables are and declare those. Then we're going to get the player choices, the player and computer choices. Then I'm going to analyze those choices and see who won, right? Determine a winner. Maybe I'll write it that way. And then I'll have my my output of the results. So that's going to be the basic structure, at least for the moment, of my game. And I want to get right away to something that's going to be potentially difficult with this problem, and that's the idea of a random number. It turns out that the book has a little chunk of code provided for us just above this on the page where we can see one way that we can generate random numbers, and there are a couple potential different ways to do that. But to do that, we're going to need a random object, and I don't want to get sidetracked on what the mechanics of this, but we're just going to use the code. So equals new random, and so RNG stands for random number generator, and I'm just going to acknowledge that this is from my textbook on page, let me look what the page number was here. Oh, my ebook doesn't have page numbers, so I hadn't thought of that. I'm going to say textbook module 4 programming exercises, and as always, it's important to acknowledge when we get some code from somewhere else. So I'm going to need that, and we're going to come back and talk about that in just a moment. But what it can do for us is generate a random number for whatever range we need, and that's the way we're going to implement the computer choice. Before I get to that, though, I need to make another decision about the data type I'm going to use to keep track of these player choice and computer choices. So I'm going to have a variable called player choice, and I'm going to have a variable called computer choice. The two most obvious options for a data type on this would be a string, so that we could have the word rock or paper or scissors, or perhaps a char. So we could put an R, a P, or an S, and those are both fine. They both would work perfectly well. What I'm going to do, because as I am thinking about how we're going to be generating a random number, I'm just going to use a random, or a number, excuse me, to represent these choices. And so this may seem odd at first, but here's what I'm going to do. I'm going to say that if somebody chooses rock, that's equal to 0. If somebody chooses paper, that's equal to 1. If somebody chooses scissors, that's equal to 2. It's essentially the same thing, and it's totally arbitrary what numbers I use. But what I'm going to do is I've already forgotten, like, wait, did I say rock was 0? I'm going to make constants to keep track of that. And this choice that I'm making hopefully will become a little more clear as I keep coding why I'm choosing to do it this way. But I'm going to make 3 constants. If you know what an enumeration is, this is a great place to use them, but it's kind of beyond the scope of what we're going to do right now. So I've decided that these are the values for these different choices, and again, they're arbitrary. I could have made rock 947, and paper could have been 17, and scissors could have been 4,298. It really doesn't matter, because what I'm interested in is these identifiers. Now I can just say rock whenever I am referring to rock, and I can say scissors when I'm referring to scissors. This is the advantage of using constants and helping make our code more readable. As I skip down now to how do we get a computer choice, you're going to see this pay off. So I'm going to say that computer choice is equal to, and again I'm getting this code from the textbook, rng.next, and the next method has 2 arguments. I can specify the minimum number that I want and the maximum number that I want. And so at first it looks like this is a good choice. I want a number between 0 and 2. What we have to be careful about, and Visual Studio tries to warn us of this, is that the minimum value is inclusive, but the maximum value is exclusive. So if I want 0, 1, or 2, then my maximum value is 3. So that's a little bit odd, but that's the way most programming languages seem to do it. And here's what I've just accomplished: is computer choice is going to be a random number 0, 1, or 2. If it comes up 0, that means computer chose rock. If it comes up 2, it may chose scissors, and if it comes up 1, they have chosen paper. So I've kind of saved myself. The other way I could, it was a little bit of work. The other way I could have done this is to say, generate my random numbers, and then have if statements that say, well, if the computer chose 0, then as a string, computer choice equals quote unquote rock. So that works fine as well. And we're actually going to see a small version of that with our player choice, so that's why I figured I can show both ways. So for the player to choose, we need a little bit of user interface here, and the program specifies that the player is supposed to enter R, P, or S to make their choice. So let's start setting this up a little bit. Let's say console write choose rock. So I grew up playing a lot of text-based adventure games when I was a young child, so I have a certain interface that I kind of default to. These the idea that we're going to kind of indicate with these brackets what they're supposed to pick. And now we'll say that so the player choice is going to eventually be an int, but I need to get the input as a string and then do some kind of a conversion, right? So I'm going to need another variable for that, and so I'll just call that input. And again, I like to initialize all my variables as I go. So I'm going to say input equals console dot, let's take the whole line there, read line. And I'm also going to kind of slip in this to lowercase call. So what that's going to do is whatever they type in, it's going to convert that into lowercase so that I don't have to deal with, well, what if they put in a capital R? My user interface, especially for as we're beginning programmers here, does have a lot of potential problems here. What happens if they type in the word rock or something like that? Those are things that we'll learn to handle better down the road. For now, we just have to live with them as a limitation of our program. But that one is easy enough to do. Just convert it to lowercase, and they can get away then with typing a capital R. And so what I need to do now is I've got the user. I like to run this here, and let me put a console.readline at the end to just terminate my program there. I like to run this and sort of see how my program looks so far. Okay, so far so good. It's prompting me and it's popping up asking for my choice, and then it sits there and waits for me to close it. So, so far so good. What I'm going to point out is that as long as I'm working through this idea of choice, maybe I should output the computer's choice so that I can see if my random number generator is working. So computer choice. Now, clearly, this makes for not a very good game if we're going to sort of spoil it every time and tell the player what the computer has chosen. But my purpose here is to run this a few times and make sure that I'm A, getting different numbers each time, and B, getting numbers that are only within a valid range. So if I run it and it comes up with 2 every time, that's a problem. If I run it and I see all of a sudden the number 7, then that's a problem. So I'm just going to do a couple tests here. And oops, I got 2 again. And sometimes students start to get a little nervous, like, well, wait, I got 2 twice in a row. Well, there's only 3 choices. So it's pretty common to kind of get the same choice, get a little streak every once in a while. And I won't make you watch me do this over and over again, but I'm going to keep running it until I get a good little sample of data to make sure that my random number is working correctly. So I feel pretty confident that my computer choice is working correctly. It's getting different values every time. And at this point, I'm going to kind of oops, wrong line of code there. I'm going to turn off this this output because I don't really want to see that as part of my game. I'm not going to delete it though because that might be useful later. So computer choice seems to be working well. My next step with my player choice is, well, I've got their input as an R, a P, or an S. I need to convert that now into an int. So I'm going to use a series of if statements for that. So I'm going to say if input is equal to R, and remember I only have to check lowercase, then we're going to say player choice is equal to rock. And again, that makes it easy. I don't have to worry about is rock 0 or what. Else if input is equal to paper. And now I've chosen to use an if structure. You sometimes hear this called like a multi-branch if structure. The idea is there are 3 choices, and I only want one of them at any given time. And I've got a typo here as I'm trying to talk and type at the same time. I only want one of them. It's never the case that I want player choice to be equal to rock and I want player choice to be equal to paper, right? So that's what an if-else-if structure does for us. Is as soon as it's found the player's choice, it's going to skip and not even bother checking the rest of these if branches. RPS player choice equals scissors. And so again, I'm going to make sure that that conversion is working correctly. Just as a matter of testing, right? Oops. Okay, so this is actually good. I didn't do that on purpose, but this is worth mentioning. After I had just talked about how I always like to initialize my variables to default values, I forgot to do it because I was talking about the data type. And this is why you want to just do that, because the computer sees this as it's possible player choice will never get set to anything. All of these assignment statements are inside if blocks. So it's possible that player choice never gets set. And so there are a couple ways to solve that. For now, what I actually like to do is I like to set my integers to -1. And that's kind of a topic for another time. -1 is like a flag value that sort of says, hey, something's wrong. And so the other thing I could have done here, one other way of solving that, is to just get rid of the if at the end. And that would have said, well, if they type in R, it's rock. If they type in P, their choice is paper. If they type in anything else, then they are choosing scissors. And that's not a bad solution because that can potentially keep our program from crashing. So maybe I'll leave that in for that. It's going to have a weird side effect if the player types in E. It's going to be like they chose scissors, but I'll leave it like that. So that was actually probably a good little mistake to make. Let me see what my other error is here. Oops. So else, if they choose R, we'll set it to rock. If they choose P, we'll set it to paper. And if they don't choose either of those, then we're going to give them scissors. So that seems like a reasonable choice here. So player's choice is 0, and we have to sort of know, well, okay, 0 means rock. And let's try paper, good. And then my last test case here, or my last test of this part of the program, if I type in anything else, it should give me 2, including if I type in something totally random. That happens to have an S at the end, right? They chose scissors, so I can live with that, and the book doesn't specify how to handle that, so that seems fine to me. Okay, and then once again, once I have tested that, I don't really need that output. The player doesn't need to know that these are getting converted into zeros, into integers. So the next part is to determine the winner and then output the result. And so it sounds like I'm going to need another variable here, a string that indicates which player won, so to speak. So I'm going to make a string called winner, and I'll set that to an empty string for now. And I can actually kind of skip ahead here. I can say console.writeLine and so now all I have to do is determine who won, set my string that's called winner to that person, to that player, and then my program should be finished. So this is where things get interesting. How do we determine who wins a game of rock, paper, scissors? Well, the first case that I want to handle is what if it's a tie? What if it's a draw? And the way we get a draw is if both players pick the same thing. And so I could say, well, if player's choice is equal to rock and the computer's choice is equal to rock, or if the player's choice is equal to paper and the computer's choice is equal to paper, and all that would actually work fine, but it's a lot of code to write, and there's an easier way. What if I just say if the player's choice is equal to computer choice? If player choice is equal to the computer choice, then we just say it's a draw. Okay. And if it's a draw, we don't even have to bother checking for anything else. So this is going to be an if-else situation. So that's the easy one. Now we've got this weird combination, or not weird, but we've got this big combination of other potential outcomes. And here's the way I would tell you to break it up. Imagine that you're actually playing a game of rock, scissors, paper with your friend, and imagine you could slow your brain down to this really slow speed where you're actually conscious about the decision you're making. Because in reality, of course, you throw out your rock, your scissors, your paper, and you kind of instantaneously can tell if you won or lost. But what's really happening is you're making your choice for what you're going to pick, rock, paper, or scissors. Then you're looking to see what the other player's choice is, and you're making a quick comparison. You're saying, okay, I chose rock, so if I look and if they chose paper, they won. But if they chose scissors, I won. Um, so let's kind of model that out a little bit. Let's say that the player choice is equal to rock. If I chose rock, and the player chose rock, that's already been handled in our draw situation. So I don't have to worry about that anymore, right? The else statement ensures that if this is the case, it's not going to check any of the rest of my code. So now all I have to worry about are the other two potential choices. What if the player chose scissors? What if the player chose rock? Well, that can be just another if statement, right? Maybe this is a good place to point out that this isn't the only way to implement this logic. You could very easily and very effectively use and or statements, what I would call compound Boolean expressions, and that would be great. And if you solved it that way, there's no reason to delete that and change it to my way. But I'm just trying to kind of talk through some logic here. So we call this a nested if statement. I'm going to put an if statement inside of another if statement. So if my choice is rock, then if the computer choice is equal to paper, then the winner is the computer, right? The paper covers rock. Okay. Otherwise, the winner is me, is the player, right? Again, those are the only two situations we have to worry about because we've already handled the draw. Okay. And it's downhill from here because that's what I do if my choice is rock. Well, what if my choice is, now it's just repetition of the same thing. What if my choice is scissors or paper or whichever one you want to do next? Player choice is equal to scissors. Then okay, well I've already handled what if I chose scissors and they chose scissors. So all I have to do are the other two choices. So if the computer choice is equal to rock, what happens? Otherwise, what happens? So if the player chose rock, they won. If the computer chose rock, then they won. Okay. Otherwise, I won. I'm tempted to copy and paste, but I always make dumb mistakes when I do that. So I'll just go ahead and write out the last possibility here. So I've taken care of what if I picked rock, what if I chose scissors, how about if I chose paper? And I caught myself starting to do what many beginning programmers do, real common mistake to leave off that second equal sign. We pronounce this is equal to, so if player choice is equal to paper. Okay, so if the player chooses paper, then, well, what if the computer choice is equal to rock? Well, if the player chose rock, then I win, right? So winner equals player. Otherwise, the computer wins. Now, I've mentioned a couple times that there are some testing concerns with a program like this one. If I run it and I say rock, okay, I won. I have no way of really verifying that this program worked correctly, and this is a big problem. We certainly don't want to turn in code, for an assignment, for an example, if we don't know for sure that it's working correctly. So there are a few things we can and should do to verify this. One is that we probably should modify this output so that so that it's a little more clear what is going on. And so my little winner string here could probably have a little more detail. Let's say players, computers, paper, Smothers, players, rock. Okay, and I can do that for each of these different outputs. I won't make you watch me type them all, but okay, so this one is players, players rock, smashes, computers, scissors. I could make unique output for each of my different cases, right? So that I've come one step closer. Now, at least when I run it, I can see I can see a message that indicates which happened, and that's going to go a long way. Another thing I could do instead of that is just turn these back on, these little statements that indicate what my choice was and what the player's choice was. That would also give me some feedback on that as well. But I'm thinking that the player doesn't want to just be told that they won or lost. They might want to see what the other player picked as well. So that's one thing. That the problem that doesn't address is that I've got to play this game a lot to see if it's working, because I got to keep trying. If I'm picking paper, I got to keep playing until I've seen the computer pick paper and the computer pick rock and the computer pick scissors, so that I know that all three of those possibilities work. Now I can go on to the next choice, and I got to keep playing it over and over and over again. So one of the things that I'm going to do as a tester is I'm going to get rid of this randomness, and I'm just going to say computer choice equals rock. And now I'm going to go test my code. And I'm going to try all my different choices. I'm going to pick rock and make sure it's a draw. I'm going to pick paper, make sure that I win. I'm going to pick scissors, make sure that I lose. And then I'm going to come in here and I'm going to change this to paper. I'm going to test all three cases. I'm going to change it to scissors, test all three cases. And then very importantly, I'm going to then delete that line of code or comment it out. And a lot of times students will leave it in and just say that it was for testing, right? And that's always a good idea too. That then you have proof that you tested it. So I'll want to go through all of that kind of rigorous testing before I wrap this up and submit it. But that's the basic idea. I've got two different if structures here. I've got one standard if-else to kind of determine convert from player input into a number. And then I've got these multi-branch if statements with nested if statements inside of them to determine a winner. So I think that does it for this program.